Hello Math 1B, I've got a new video for you. We're going to be continuing to talk about how systems of equations can be solved not really just by graphing. We talked about substitution the other day, and I'm going to give you guys a new method in this video, but I first wanted to talk about how you can use substitution to solve one that looks really messed up. What I mean really messed up is there doesn't seem to be any variable that is just jumping out at you to get by itself right away. See, if there's a coefficient in front of the x's or the y's, it makes it really hard to create clean numbers out of that. So I'm just going to pick one at random. Since none of them seem to be dividing 29 or 43 very well, I believe those are both prime numbers. So they're not going to divide anything but 29 and 1, 43 and 1. And none of these are coefficients for the others. So I'm going to put in red that, hey, dividing by 5 either creates usually like a decimal that terminates, that ends. It's not like repeating. So I'm just going to go with the 5. So step 1, I've identified the variable I want to get by itself. I'm using the second equation, and I'm honing in on the y variable. So I'm going to take this, solve for y. So we subtract 6x from both sides, leaving you with 5y is equal to, remember, 43 minus 6, that is 37, but not if there's an x connected here. Order of operations says the 6 has to be multiplied by the x first, can't just randomly subtract from the 43. So, as I almost write 37x. 43 minus 6x. Then we divide all parts by 5. So y equals, just do some quick math in your head, 8.6 minus 1.2x. All right, now I'm going to put, this is my red y that I'm talking about here. And I'm putting parentheses around it because that entire variable expression is going to replace the red y in the other equation, this one right here. So, this red y is sort of the same value as that red y, which is the same value as this expression here. So I'm literally saying, after step 1, step 2 is plugging into this equation. So I'm taking 3x plus 4. Instead of y, I'm plugging in 8.6 minus 1.2x. I'll write that a little more clearly for you guys. And that all equals 29. Sorry, we're getting a little crowded here, All right, now the success of this is that we got an equation with just x's in it. So now I can solve for x. So drop the 3x down, take the 4 times 8.6, that's 34.4. Take the 4 times negative 1.2x, it's minus 4.8x. You get 29 here. Since there's only one constant on the left, I'm going to move that right away to the 29 on the right. Thus, canceling it on the left, 3x minus 4.8x is going to be negative 1.2x. And then you're going to get negative 5.4. I'm sorry, this is negative 1.8x. Forgive me. Equals negative 5.4 on the right. You divide by that negative 1.8 to clear the coefficient in front of the x. Now the coefficient's a 1, which makes it just x. So x is equal to negative divided by negative is a positive. This is the same thing as like 54 divided by 18. 18 goes into 54 exactly 3 times. We've solved for x. Took us a while, but we got x. Now, you got a couple options here. You can plug this 3 equals x into the top equation, the bottom equation, or the new equation where y is already by itself. I've been encouraging you guys to plug it into this equation because, again, we're solving for y Y is already by itself, so just do the straight plug-in right here for this x. So this y equals 8.6 minus 1.2 times 3. And I ditched the grouping symbols here with the parentheses just because I'm not plugging it into something else. I'm just using it as it is right now. So 3 times 1.2 is 3.6. 8.6 minus 3.6, 5. All right, x equals 3, y equals 5. 3 comma 5 is the point at which these two linear equations, when we graph them, they will intersect at that point on a grid. But substitution is not the only way. There is another method that I think you guys will find a lot more convenient, especially when you've got a system that is set up just like this. So the alternate method, we call it elimination. The reason why we call it elimination is because we want to get rid of one of the variables right away. So the idea is by column addition or subtraction. If you can get the coefficient in front of the x's to be the same number, or do it in such a way that their operations cancel each other out, and you're left with 0x, or the same thing with y, adding or subtracting to get rid of it, then we can solve a lot quicker. So the idea is, ask yourself, what's like a common multiple between 6 and 3? A number that'll divide them both evenly. Now, some of you maybe have figured it out already, like, hey, 3 times 2 is 6. We can make those numbers the same just by multiplying the top by 2. Here's what I want to do, though. I want to create a circumstance where all I got to do is add the columns. So if I just multiplied by 2, I'd get 6. 6 plus 6 is 12. That did not get rid of the x's. However, if I multiply that thing by negative 2, negative 6x plus 6x will zero it out. So I'm gonna stick with that strategy from here on out. I would advise you to follow me on that. So negative 6x, okay? And now I got to multiply everybody by the negative 2. That's negative 8y. That's equal to negative 58. All right, down here, you get 6x plus 5y equals 43. Hey, I didn't change it because I brought the first equation to match the second equation, basically. All right, what do we do next? Add. That zeroes it out. And if I add these, then I have to add these. Negative 8 plus 5, that means subtract the 2 and take the sign of the bigger one if they're opposites. Negative 3y. Same deal with this one, negative and positive. Let's see here, negative 15. Divide by negative 3. Now from here, you actually, if you want to get the y's to be the same and do the exact same thing, you can do that. But realize this, once you find y, you literally can take any of the equations, like this one, and say, y is 5. Take the y out, put a 5 in there. And now I have an equation that is easily solvable. So take 5 times 5, 25. Move that constant to the right. Always opposite operations. That equals 18, and then divide by 6. X is 3. So we're going to get the same answer. And I don't know, this probably method, if you haven't seen it in a while, doesn't feel as convenient as it actually will be with more practice. So let's get some more practice. All right, so some examples for your journey. I didn't seem to give a whole lot of room here, so bear with me. This is 2x minus y equals 4. 7x plus 3y equals 27. Which one of these variables do you think is going to be more convenient to work with? Yeah, you're right. It's the y. If I have 3y down here, all I got to multiply this top by is 3 to get an opposite y value. That's negative 3y. So multiply by 3 and you get 6x minus 3y equals 12. And then the bottom can just be rewritten. Add each column. Because that eliminates the y's, and negative 3 plus 3 is 0y. This gives you 13x. This gives you 39. What is 39 divided by 13? It is 3. So I got the x coordinate pretty quickly there by using the elimination method. Now the question is, which equation do we want to plug back into? This one has only positives, but it has bigger numbers than the top one. This is all based on preference, so pick whichever one. Eeny, meeny, miny, 2x minus y equals 4. So 2x minus y equals 4. I am replacing the x with a 3. So 6 minus y equals 4. Well, it's 6 minus 2 equals 4. I know the answer is 2, but here's how you would do it if you wanted to show all those itty-bitty steps. Negative y equals negative 2. That's technically a negative 1 in front of the y. Divide by negative 1, divide by negative 1. Y equals 2. So your answer is 3, 2. I'm going to skip to number 3 because I think I have time for one more example. Pause it, try it on your own first. All right, so we've got some messy numbers to work with. I'm looking at 2 and 3 and thinking 6. 6 divides 2. 6 divides 3. It's a pretty small number to work with. Let's make one of them negative, though, so that we can straight up add. So I'm going to multiply the top by negative 3. That'll create the negative 6y here. And then the bottom by positive 2. So I'm actually going to, let me write this below so that you guys can see it better. So negative 3 times 4x is negative 12x. Negative 3 times 2y is negative 6y. And negative 3 times negative 14 is positive 42. On the bottom, 2 times 5x is 10x. 2 times 3y is 6y. 2 times negative 17 is negative 34. Make sure you pay attention to those pluses and minuses. It's really going to hit hard on this one. So add, add, add. The y's are gone. Negative 2x remains. Positive 8 remains. Divide both sides by negative 2. You get x equals negative 4. Take that negative 4, plug it into any of the original equations. I'm going to go with the top one. So it's 4x plus 2y equals negative 14. Negative 16 plus 2y equals negative 14. Add this 16 to both sides. This will be 2. Divide by 2, divide by 2. Y equals 1. And there you have it. Y equals 1 here. X equals negative 4 here. Good luck.